Welcome back to another episode of Giraffes Wear Math Socks. I'm your host, Mr. Cavender, and let's get started. We're ready for lesson 7, which is going to have to do with factors and multiples. Okay, so the best way to think about this is, what is a factor? Okay, a factor is going to be a number that multiplies with another number to get a number. So as crazy as that sounds, it's easier if we look at it on paper. So the factors of 12. Okay, and the way I like to write this is we're always going to start with 1 and that number, but we're going to leave ourselves some space. So I know that 1 times 12 is 12. So I'm always going to check for 1 because I know that's going to work every time. Okay, there are types of numbers that the only factor pair they have are 1 in themselves. Those are prime numbers. And we're going to, we'll talk more about those in the week as well. So the next number I need to check for is the number 2. Okay, any even number is going to have 2 as a factor. So 2 times what will give me 12? Well, 2 times 6 will give me 12. Okay, what about 3? I know that 3 times 4 will give me 12. So the only ones I had to check for on this one were 1, 2, and 3 because I saw when I got here 3 met up with 4. So you're kind of working your way from that number and 1 and working your way in and filling in the gaps. Okay, let's look at a different one. Let me use this so you can see maybe a little bit better. Let's do factors of 32. Okay, so I know it's going to be 1 and 32. That's always going to be the starting. We need to check for 2. Is 32 an even number? Yes. So 2 times what will give me 32? Well, that would be, I know that 15 times 2 is 30. So 16 times 2 would be 32. We need to check for 3. Now, the way I check for 3 is if we take the 2 or however many digits in the number and we add them together. So in this case, it would be 3 plus 2 is 5. If 5 is one of the multiplication tables of 3, or if whatever you add together here is one of the multiplication tables of 3, then it will work. Now, because when I add 3 plus 2 together is 5, 5 is not one of the multiplication tables of 3. It goes 3, 6, 9, so it skips over 5. So 3 will not work on 32. I also need to check for the number 4. If 2 works, there's a chance 4 might work. I know that 4 times 8 is 32. So you see how it's closing down here. So the only options I have left are 5, 6, and 7. So is there anything that I can multiply by 5? No, because it has to end in a 5 or a 0 to be divisible by 5. So 6 does not work, and 7 does not work. So 1, 2, 4, 8, 16, 32. Okay, let's look at 36. This has a special case to it. You already know we're supposed to start with 1 and 36. Okay, that would give me 2 and 18. No. Yeah. All right, sorry. And then that would give me 3 would go with 12. 4 and 9. 4 times 9. And that gets me down here to 5 will not work because it does not end in a 5 or a 0. And that leads me to 6. I know that 6 times 6 is 36. So when we list these, if it's a double, like 6 times 6 or 7 times 7 or 2 times 2, you only list that number one time because there's only 6 is the factor of 36. So the factor pair would be 6 times 6, but if I'm just listing the factors, I'm only going to list it one time. Simon had a lot of factors. Let's look at something like 17. Well, I know 1 and 17. Well, 2 won't work because it's odd. 3 doesn't work because 7 plus 1 is 8. 8 is not a multiple of 3. 4 doesn't work. 5 doesn't work. 6 doesn't work. 7 doesn't work. 10 doesn't work. None of our, excuse me, none of those work. So the only factors of 17 are 1 and 17, and that makes it a prime number. All these other that we did are composite numbers. So composite numbers are numbers that have multiple factors other than 1 in itself. So if it has any other factors other than 1 in itself, then it is a composite number. If it just has 1 in itself, then it is a prime number. Okay, let's talk about multiples. So multiples are just like our multiplication tables. If I want to know the multiples of 2, then I'm just going to count by 2. I would say 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and I can go on forever here counting by 2s. Those are the multiples of 2. So when you think multiples, think multiplication tables, because I'm literally just counting by that number. Okay, so if I want the multiples of 5, I do 5, 10, 15, 20, 25, 30, so on and so forth. Multiples of 25, do 25, 50, 75, 100, 125, 150, so on and so forth. So when you do the multiples, you're just counting by that number. Okay, let's look at a couple questions before I sign off here. So here's a good visual picture of what we're talking about with factors. You see the factors of 16 in array models here. So I could do 1 times 16. I could do 1 row of 16 chairs, 2 times 8, 2 rows of 8 chairs, a 4 by 4, 4 rows of 4 chairs, 8 times 2, 8 rows of 2 chairs, or 16 rows of 1 chair. So the factors here are going to be 1, 2, 4, 8, and 16. Factor pairs will be 1 and 16, 2 and 8, 4 and 4. So complete the list to show the factors of 12. So I know 12 is going to come last. So 1 and 12, 6 went with 2, and 3 goes with 4. Okay, so see how I did that? Write the factor pairs of 12. So I know that 1 went with 12, 2 goes with 6, and 3 goes with 4. All right. I just wanted you to show that. We're going to look at 2 more problems, and then the time will be yours. So these cupcakes are packed into a box, or excuse me, cupcakes are packed 6 to a box. If Abby only buys full boxes of cupcakes, give 2 possible numbers of cupcakes that she could buy. So if there's 6 in a box and she only buys full boxes, then she could buy 6, 12, 18, 24, 30, 36, so on and so forth. So what did I just do here? Did I do factors or do I do multiples? Can't hear you. I'm hoping you're saying multiples. Multiples, yes. Because look, I'm just doing the multiples or the multiplication tables of 6. So she could buy 12 cupcakes, or she could buy 24 cupcakes. Any of those would work there. Strawberries are sold 1 pound, 2 pound, and 5 pound boxes. Stacy wants to buy exactly 10 pounds of strawberries. What are 2 ways that Stacy could buy exactly 10 pounds of strawberries? Okay, she could do 10 1 pound boxes. She could do 5 2 pound boxes. That says LB. Or she could do 2 5 pound boxes, because those are all factor pairs there. All right, that's my time. So I will see you on class Monday, and have a great weekend. Peace.